This boy name is Smith. He is from England and he speaks English language. He has a friend, his name is Daniel. He is from Spain and he speaks Spanish language. He has another friend, his name is Wang. He is from China and speaks Chinese language. As you can see, the different people who living in different country, they speak different language. Then what about the computers? What language your computer speaks? As we know, in this era, the computer are the best friend of humans. They are using the computer to do so many things that you can't even imagine. One of the things I was wondering in this situation is how the humans are communicating with the computers and how the computers are communicating with humans. The computers and humans are using entirely different language. The computer is an electronic device and their language the human cannot understand directly. In the same way, the human's language cannot understand by a computer directly. So then how this communication is happening between the humans and the computer? So in this chapter we are going to discuss about most common numbering system that used by the computer and humans, and we call it binary and decimal numbering system. Welcome to the video. Welcome to CCNA 200-301 Implementing and Administering Cisco Solutions, chapter number 52, Binary and Decimal Numbers. In this chapter, we will talk about the binary number system. Then we will talk about the decimal number system. And finally, we will talk about the differences between the binary and decimal system. Computers are the electronic devices. They cannot work in their own. They need to get the instruction from humans, applications, or any other devices. So in this situation, humans speak a different language, which would be English, Spanish, Chinese, or Hindi. The applications speak a different language like Python, Java, C language, etc. And the other devices, maybe they're using a different customized language. So how the computer is going to understand the languages from this human, from this application, or from the other devices? Because they are entirely different language. And computer doesn't know all this language. So in this situation, the different language from the different sources must be converted into a language that the computer can understand. And in the same way, the output that given by the computer must be converted back to the specific language of the source so that they can understand. So basically saying the computers are using a different language, which is a machine language or binary language. So whatever the instruction it is getting from the human or the application or the other device, it must be converted into that machine language or to that binary language so the computer can understand what is that instruction. In the same way, when the computer deliver the report, deliver the output, they deliver it in the same machine language or binary language or the binary system. And the same output, it must be converted into the different form. Then only we can understand what is the content. In this chapter, we are going to talk about the binary and decimal numbering system. These are the common numbering system that exist in this world. Here, the binary is used by the computer and decimal is used by the humans. So let's see what are those and what are the difference between them. Here first we will talk about the binary numbering system. What is the binary numbering system? The binary numbering system is a way of representing the numbers using only two digits. They are zeros and 1. So in binary numbering system, there is only zeros and 1 is available. So the binary numbering system is made up with only zeros and 1s. In the screen you can see the example of a binary number system. And you can see it contain only 0 and 1s. It doesn't contain any other numbers. So this is the example of a binary number. Now here, what is this zeros and 1s? What they are representing for? So as you know, the computers are the electronic devices. They are using digital electronics to process their brain. So in digital electronics, we have only two states. One is on state and other one is off state. So what is this on state and off state? In digital electronics, the signals are processing in the form of zeros and 1. 0 means it is a 0 voltage and 1 means it's a positive voltage. It can be 5 volt or 10 volt or any other value. So in this graph you can see two different axes. One is X and another one is Y. The X axis represent the time and the Y axis represent the voltage. And you can see the electric signals are passing in the form of zeros and ones. Whenever there is a positive value, it is considered as 1, that means the on state, and whenever there is a 0 value, it is considered as 0, off state. So in our example of this binary number, this 1 indicate the on state, the 0 indicate the off state. Again 2 1, they are on state, and then 2 0, they are off state, and again 1 on state and 0 off state. This is the way of computer understand the signal that it receive. The binary numbering system is also called a base 2 number system because it uses 2 as its base. The position of each bit represents a power of 2 starting from the right. So in the binary numbering system, each bit represents the power of 2. That is also starting from the right. So here you can see from right side, the first bit represents the value of 2 power of 0. The second bit is 1 and it represents the value of 2 power of 1. The third bit is 0, it represents the value of 2 power of 2. The fourth one is 0 again, it represents the value of 2 power of 3. Then the fifth one represents the value of 2 power of 4. Sixth one represents the value of 2 power of 5. Seventh one represents the value of 2 power of 6. And eighth one represents the value 2 power of 7. So here what is the power of 2 represent? The first one is 2 power of 0. What does it mean? Any number that has power of 0 is equal to 1. So 2 power of 0 is equal to 1. If it is 3 with the power of 0, again it is equal to 1. So any number with the power of 0, it represented by number 1. Then the second one is 2 power of 1. Any number that is with the power of 1 is equal to the same number. So here 2 with the power of 1 equal to the number itself 2. Then the third one is 2 with the power of 2. That means the number 2 should be multiplied by 2 times. That means 2 into 2 it is equal to 4. Next one 2 with the power of 3. That means the number 2 should be multiplied 3 times. That means 2 into 2 into 2 that is equal to 8. Then fourth one 2 with the power of 4. Multiply the number 2 4 times, then we get 16. The next one multiply the number 5 times, then we get 32. Next one multiply the number 2 6 times, then we get 64. Next one multiply the number 7 times, then we get 128. And when we calculate the whole number of this 8 bit, then we get the number 255 altogether. This means that by using an 8-bit binary number system, the maximum value we can represent is 255. So if we want to represent any other number that is greater than 255, then we need to increase the number of bits. So from 8, it need to increase to 9, 10, 11, 12 and so on. So by using this 8-bit binary numbering system, the maximum value we can represent is 255. Each digit in a binary number system is called a bit. That means in our example, this 1 is called a bit, this 0 is called a bit, again this one is a bit, this one is a bit, and this all are called bit. And when we add all this bit together, I am going to add all the bit here, then we get the total value of 8 bit. So that means this example which I give here, the binary number system, it is an 8-bit number, and this 8 bit is called 1 byte. When there is an 8 bit together accumulate, then we call it a byte. Now let's talk about the decimal numbering system. The decimal numbering system is the standard system we use for counting and representing numbers in everyday's life. And this is applicable for humans like you and me. A decimal number is made up with 10 values. They are starting from 0 to 9. That means 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Any decimal number, smaller or bigger, it is made up with these numbers only. It also called the base 10 number system because it is uses 10 digits starting from 0 to 9. So these 10 digits are using to create all the decimal numbers, so that's why they are calling a base 10 system. As you learned in binary number system, binary numbers are made up with only 2 numbers. They are 0 and 1. That's why they are called base 2 number. And here we are using 10 digits to create a decimal number. So decimal number is a base 10 system. And what is the example of a decimal number? I give you some example of decimal number. They are 210, 500, 1200, 5400, etc. Whatever the decimal number is, they all are made up with these 10 digits starting from 0 to 9. The position of each bit represent a power of 10 starting from the right. So this is an example of a decimal number. You can see. And what is the value of this number? This is called 1,50,24,321. And in this decimal number, as we said, each bit represent the power of 10, and that is also starting from the right side. So we can say the 1 represent 10 with the power of 0, 2 represent 10 with the power of 1, 3 represent 10 with the power of 2, 4 represent 10 with the power of 3, 2 represent 10 with the power of 4, 4 represent 10 with the power of 5, 5 represent 10 with the power of 6, and 1 represent 10 with the power of 7. So when we calculate its value, it's coming like this. 10 with the power of 0 indicate 1, 10 with the power of 1 indicate 10, 10 with the power of 2 indicate multiple 10 2 times, then it is 100. Next one, 10 with the power of 3. Multiply 10 3 times, then we get 1000. Next one is 10 with the power of 4. Multiply 10 4 times, then we get 10,000. Then 10 with the power of 5, we get 1 lakh. That means 100,000. Then 10 with the power of 6, we get 10 lakh. That means 1 million. And next one is 10 with the power of 7, that indicate 1 crore. So this is the value of each bit representation in decimal numbering system. Let's see what are the difference between the binary and decimal numbers. In the screen, left side you can see the specification of binary numbers, and at right side you can see the specification of decimal numbers. The binary numbers are with the base of 2, but the decimal numbers are with the base of 10. The example of binary and decimal are given here. The digital used in binary number system are zeros and 1 only. On the other hand, the digital used in decimal number system is from 0 to 9. That is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The binary number system are used by the computer and digital devices. On the other hand, decimal number system are used by the humans in daily life. Another point is, for computer, decimal to binary conversion is required to read the content because computers can only understand the binary number system. On the other hand, for humans, binary to decimal conversion is required to read the content because for humans, decimal can easily readable, but the binary it is little bit difficult to read if it is a large number. So these are the main difference between the binary and decimal number. Now we came to a conclusion like computers are using binary number system to read the data and the humans are using decimal number system to read the data. So how they can communicate together? In this situation, a binary to decimal conversion and vice versa need to be implemented between the humans and the computer. So how to convert a binary number to decimal? How to convert a decimal number to binary? We will discuss about this conversion in our upcoming chapters. So stay tuned. So in this chapter, we have discussed about the binary number system. We have discussed about the decimal number system. Finally, we have discussed about the differences between the binary and decimal system. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using iRash Academy.